Let's talk about polygons. What's required for a figure to be considered a polygon? And how can we describe polygons based on their sides and angles? First, let's start with something that you've probably been learning since elementary school, which is the names of polygons based on the number of sides that they have. For example, we've done a lot with three-sided figures already this year. Those are called triangles. So see if you can go ahead and name all of the other types of polygons that you see on the screen based on how many sides they have. For a four-sided figure, you might have said something like square or rectangle, but those are specific kinds of four-sided figures. If you're just referring to any four-sided figure, we call that a quadrilateral. A five-sided figure is called a pentagon. A six-sided figure is called a hexagon. These first four polygons you probably already knew their names of, but the next ones are a little bit lesser known. A seven-sided figure is called a heptagon. An eight-sided figure is called an octagon. 9 is nonagon. And 10 is decagon. And these are pretty much the biggest polygons that we'll be talking about by name. Past that, if you don't know the name of a polygon, you can always just call it for example, a 15agon. That would be a polygon that has 15 sides, instead of calling it by its proper name. But technically, every single type of polygon has a given name. So what makes something a polygon? Well, it has to satisfy each of these conditions. First, it has to have at least three sides. If it only has two sides, then it's an angle. And if it only has one side, then it's just a line. So it has to have at least three sides in order to be considered a polygon, and that relates directly to the next stipulation, which is that it has to be closed. If it only has two sides, then it's an angle, and angles aren't closed, as opposed to a triangle where that third side closes the angle and creates a polygon. The next requirement is that it has no curves. It has to be nothing but straight lines that create the polygon. So a circle, for example, is not a polygon because it has curves. And the last requirement is that it doesn't cross over itself. Another way to say that is that each side only intersects two other sides. So if you think about like a bow tie, for example, that would not be considered a polygon because of the way it overlaps or crosses over itself. Some of its sides intersect more than just two sides, so that would not be a polygon. So let's take a look at a few examples and determine which of these figures are polygons and which ones are not polygons. Shape A has four sides, none of them are curves, it doesn't cross over itself, and it's a closed figure. Therefore, shape A is a polygon. Shape B, on the other hand, which is basically a slice of pizza, it has a curved side, and therefore is not a polygon. Shape C is a pretty classic polygon, that's just a parallelogram. Shape D, however, is not a polygon because it's not closed. It kind of looks like a triangle, but this third side didn't make it all the way to closing with the first side, so we would say that's not a polygon. And shape E is also not a polygon because it crosses over itself. Or, another way to describe that is that some of the sides intersect more than just two sides. For example, this slanted side intersects this top horizontal side, this bottom horizontal side, and also the other diagonal side. That's three different intersections for one line, and therefore it's not a polygon. And then last but not least is F, and F is most definitely a polygon, because it has more than three sides, it's a closed figure, none of the sides are curves, and it doesn't cross over itself. Let's talk about how to name a polygon based on the names of its vertices. We've already learned how to do that for triangles, and we learned that you draw a triangle symbol and then write the three vertices in any order that you want to. But triangles are actually the only polygon that you draw the shape in front of the letters. For everything else, quadrilaterals, pentagons, octagons, and so forth, you just write the letters, but you don't have to draw that shape in front of the letters. The order of the letters or the order of the vertices is important, though. They have to go in a consecutive order. You can go either clockwise or counterclockwise, that doesn't matter, but you can't go across the shape when you're picking the vertices. You have to go around the outside of the shape. Let me show you what I mean. Here we have a pentagon. It has 5 sides and 5 angles. To name this, we could do any of these and a whole bunch more. Each of these is an example of picking one vertex to start with and going around the shape and listing the letters in a consecutive order, like penta. P-E-N-T-A. Or you could also start at A and go the opposite direction, A, T, N, E, P. So just pick one vertex and go around the shape in either direction. And although some of these kind of form words, like you could technically say that this is penta, or atnep, or tapin, we don't usually say the word that's created by the letters, we just say P-E-N-T-A, or A-T-N-E-P, etc. So those are some correct names that you could give to this polygon, but what about some incorrect names? P-N-E-T-A would go across the shape, P-N, that goes across the shape, E-T, that goes across the shape, A, that's an incorrect name for this polygon because it doesn't go in a consecutive order. Same with A-N-T-E-P, that crosses over the shape instead of going around the outside, so that's an incorrect name. And finally, let's talk about how to classify polygons based on what their sides and their angles are like. A polygon is equilateral if all of its sides are congruent, and equiangular if all of its angles are congruent. We've actually already seen these words when we talked about triangles. And with triangles, we learned that if it's equilateral, then it also has to be equiangular. But that's not necessarily true for all of our other polygons. Just because a quadrilateral, for example, has 4 congruent sides, doesn't guarantee that it will also have 4 congruent angles. But if it does, if it has both all the sides are congruent and all of the angles are congruent, it actually gets a special classification, which is called regular. So let's classify each of these polygons based on their sides and their angles. Shape A has 5 congruent sides and 5 congruent angles. That would mean that it's both equilateral and equiangular, and therefore we call it regular. Shape B has 4 congruent sides, but it has only 2 pairs of congruent angles instead of all 4 angles being congruent. So I can only classify it according to its sides being congruent, therefore shape B is equilateral. Shape C has 2 pairs of opposite sides that are congruent, so it's not equilateral because not all 4 sides are congruent. And you might say, well, it's not equiangular either because these angles aren't marked as congruent, they're marked as right. But according to the right angles congruence theorem, all right angles are congruent, so yeah, I could classify C as equiangular. Shape D is kind of funky looking, but all 6 of its sides are marked as congruent, so yeah, that's equilateral. Shape E has 2 pairs of sides that are congruent, but not all 4, so it's not equilateral. And it has 2 angles that are marked as congruent, but not all 4, so it's also not equiangular. So we would just classify this as neither, and actually I would argue most polygons are just going to be neither. It's a pretty special case for it to be equilateral or equiangular, and a really special case for it to be regular. For example, shape F has 3 congruent sides and 3 congruent angles, so we would call that regular. And that's all you need to know about what makes a figure a polygon and how we can name them and classify them. In our next lesson, we're going to discuss how to calculate their interior angle measurements.